For the Unit 9 review in geometry, and this is about your polygons and your quadrilaterals, it says find the sum of the angle measures of each polygon. So first I need to figure out how many sides do I have. So 7 sides. So n equals 7. And so to use the correct formula, you would do n minus 2 times 180. So if I plug in 7, I have 5 times 180, and that is 900 degrees. So in part B, instead of giving you a picture, they give you the shape, and it's a pentagon, so you know that n is 5. And so if I plug that into the formula, we have 5 minus 2 times 180, and we would get 540 degrees. And number 2, find the measure of an interior angle in the regular polygons below. So if this is a regular polygon, all angles, all sides are equal. I want to know what is just one of those angles. Okay, so I have to use n minus 2 times 180 divided by n. So here I've got 1, 2, 3, 4, 5, 6 sides. So n is 6. So if I go ahead and work it out, we get 720 divided by 6, which is 120 degrees. Okay, for an octagon, that means we have 8 angles and 8 sides. So again, plug that into the formula to find the measure of just one angle. Sorry, it should be an 8. So 6 minus 2 divided by 8. What am I doing? 8 minus 2, that's just 6. Alright, so now 6 times 180 is 1080 divided by 2 divided by 8 is 135 degrees. Sorry for all the little errors. Okay, number 3. Find the measure of an exterior angle of each regular polygon. So we discussed that in any polygon, if you add up all the exterior angles, it's 360 degrees. And if I have a regular polygon, that means that the exterior angle, all of them are going to be equal. So if I have a heptagon, I have 7 angles on the exterior, and the entire polygon would add up to 360, the exterior. If I divide by 7, we get 51.4 degrees. In part B, we have a nonagon, which is 9 sides. So 360 divided by 9 gives me 40 degrees for every exterior angle. Okay, and number 4, a polygon that is both equal angular and equilateral is considered to be what type of polygon? So this has to be D, regular. Okay. And number 5, we have a 1, 2, 3, 4, 5, 6. We have a 6-sided polygon, so we have a hexagon. First, I need to know how many degrees are in the entire hexagon. Okay, so I need to go ahead and do 6 minus 2 times 180, and that gives me 720. Then I need to take x plus all of my angles, so x plus, if I add all my angles, we get 570 degrees. And we know that the whole thing is 720. So to find x, we just subtract the 570, and we get that 150. So this angle right here is 150 degrees. Obviously, this is not drawn to scale. Number 6, we simply have a quadrilateral here, 4-sided figure. So you should know that all of these add up to 360. And I'm just going to make an equation from that. So x plus 4x is 5x. And 114 plus 136 is 250. And we know that a quadrilateral has 360 degrees. So if I subtract and divide by 5, we get 22. in number 7, for this one, I would find z first because these are supplementary. So 180 minus the 120 gives me 60. That is z. Here I have a quadrilateral. So all of these angles inside should equal 360. So if I add 95, 88, and 60, I get 243. So to find my y value, I just subtract the 243 and get 117. And that's degrees. Number 8, it says find x and y in the parallelogram below. And so in a parallelogram, you know that opposite sides are parallel and congruent. So in this case, I know that this would equal 2x plus 12, and this side would equal the 4y minus 3. So I'm just going to set up two equations. So the first one, I'm going to find x. So if I subtract 2, I get 6x. If I subtract 6, I get 6. So here x is 1. And then the second step, I set my y's equal to each other. So subtract 3, I get 1y. And if I add 9, I get 12.